Here are two more examples. Let's continue on by looking for common denominators. We don't have one in this first example. We have r plus 8 over r squared minus 4r minus the fraction r minus 2 over r squared minus 16. We do not have a common denominator here, so we need to find one. So let's factor both denominators. In the first denominator, I have a common r, so we're going to get r times r minus 4. And in my second denominator, I have a difference of squares. So when I factor that, I'm going to get r plus 4 times r minus 4. My LCD is going to be created with the denominators I currently see. Start with all of the first denominator, and then look at what's missing in the second denominator. I have the r minus 4, but I do not have in the LCD r plus 4. So I'm going to use an r plus 4 to create the rest of it. So my LCD is going to be made up of three factors, r minus 4, and r plus 4. So I'm going to rewrite each fraction that way, r times r minus 4, and then I need the r plus 4. And if I have to add an r plus 4 into the denominator, and I should say I'm adding it physically, but I'm multiplying it in the denominator, I need to multiply it in the numerator as well. Minus, and then in the second fraction, what I'm missing is the r to have that common denominator. So I'm going to multiply the r at the beginning times r plus 4 times r minus 4. And I have to multiply it as well in the numerator. So I have r in both the numerator and denominator that I needed to create that to build up the fraction to have the LCD. Now I have a common denominator of r times r minus 4 times r plus 4. In one fraction, I wrote the r minus 4 first and the r plus 4 second. I did the opposite in the second fraction. Don't worry about which one you write down as your common denominator. They're all multiplied, so you can write them in any order. With my numerators, I want to subtract, but I need to multiply before I can subtract. Order of operations, multiply before you subtract. So I'm going to FOIL out this first one, r squared plus 4r plus 8r plus 32. And then I'm going to multiply the second numerator by r, but because it's a negative or a minus, I'm going to multiply it to do both at once by a negative r. So minus r squared, and then negative r times negative 2 would be positive 2r. Now let's collect all those like terms in there. My denominator doesn't change, so I'll leave it as is. And then collecting like terms. R squared here, and I'm going to check these off to kind of show them, minus r squared is going to be 0. And then I'm going to have 4r, 8r, and 2r, which is 14r. I'll add it up. And then I only have one constant term of plus 32. Now when I look at this final fraction here, 14r plus 32, the numerator is simple or simplified, but is there anything I could factor and then cancel? Well, there is a common 2 in the numerator, but there's no common 2 in the denominator. So I could factor the 2, but there's no use in doing it in terms of actual simplification or cancellation. So most people would probably just leave the answer in this format right here. There's no harm if you wanted to take the 2 out and write it as 2 times 7r plus 16 over r times r minus 4 times r plus 4. There's no harm in that, but you don't have to. Okay? Since we didn't cancel anything, we don't have to show domain restrictions. In this next example, we have x and y together in the problem, so just remember to factor appropriately. In my first denominator, I have a trinomial, so I'm going to factor that to a binomial times a binomial. X squared goes to x and x. 20y squared, if I want the 9, I think I want to use 4y and 5y. Double check that. That will, when you multiply outside and inside, give me 9xy. My numerator doesn't change. Same thing in my second numerator, minus 2y. My denominator in the second fraction doesn't factor, so I'll leave it as 4x plus 4y. I'll put parentheses around it to emphasize it. My LCD is going to be necessary. I'm going to use all of my first fraction, x times x plus 4y times x plus 5y. And then I'm going to add in anything that's missing from my second fraction. But it turns out I already have that second denominator in there. So I don't have to change that LCD beyond what was already in the first fraction. So my first fraction has the LCD, so I'm just going to leave it as is. My second fraction doesn't. It's missing the x plus 5y. So I'm going to multiply by x plus 5y on top and bottom. So my numerator, 2x, is going to be multiplied by x plus 5y. So now we have a common denominator. You can write this out that way. X plus 4y times x plus 5y. And my numerators I can subtract, but remember to distribute before you do the subtraction. So 2xy. If you want to, it can be handy to distribute the negative at the same time you distribute the 2x. So minus 2x squared, and then minus 2x times 5y. So that would be minus 10xy. Now let's collect like terms. Negative 2x squared minus 8xy all over x plus 4y times x plus 5y. So our numerator is now simplified. Let's see if we can factor it to be able to simplify the entire fraction. There's a negative 2 that's common. There's also an x that's common. So let's take both of those out. So we're going to have an x left minus 4y. Actually, careful, negative 8 divided by negative 2 is plus 4y. So watch your signs. I almost made a mistake there myself. You can get in a hurry and make mistakes, so I always double check signs. And then x plus 4y times x plus 5y. Those x plus 4y's are common now, so they can be canceled, and we get left with the fraction negative 2x over x plus 5y, and I could just sneak it in there at the bottom. When we have more than one variable in the problem, we're not going to worry about domain restrictions when we do any cancellation, so this would be my final answer, negative 2x over x plus 5y.